All right, so today we're going to look at rectangles, squares, and rhombuses. Okay, to be a rectangle, the definition of a rectangle is it's a quadrilateral with four what? What am I drawing? Right angles. It needs to have four right angles. A quadrilateral with four right angles is a rectangle. Now, rectangles, squares, and rhombuses all share all the properties of parallelograms. So these opposite sides are parallel, the opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, the diagonals are going to bisect each other, and this side is both parallel and congruent. Okay? So, rectangles. To be a rectangle, it has to have four right angles. To be a square, it has to have four right angles and what else? Besides, what's the property of a square? All the sides are equal. So it looks like a rectangle. The only difference is it has to have all four sides congruent. So every square is a rectangle, but not every rectangle is a square. A square has to be a rectangle, but not every rectangle has to be a square. Okay? Rhombus. What's special about a rhombus? Well, it has four congruent sides. So every square is also a rhombus. Is every rhombus also a square? No, because you can see these don't have 90-degree angles. To be a square, it has to be all four sides congruent, and all four angles have to be 90 degrees. Okay? So that's some of the properties of those basic objects. Now, to be a rhombus, the diagonals have to be perpendicular. Now, if it works for a rhombus, it also works for a square. So in a rhombus, the diagonals are perpendicular. In a square, the diagonals are perpendicular. Okay? So diagonals are perpendicular. They form right angles for both of these. The other property for a rhombus that works for both a rhombus and a square is the diagonals bisect opposite angles. So these are cut in half, and they happen to be the same as each other. Okay? And then you'll have 90-degree angles right there. Okay? So this is a 126-degree angle. So it's cut in half. Each side of it's going to be 63. This is a 54-degree angle. Each side of it's going to be 27. It happens in rhombuses and squares. Okay? They're cut like that. So if it's a square, we know the angle is a 90-degree angle in the corner, right? So if we draw a diagonal, it cuts a 90-degree angle in half. So how big are each of those little angles then? What's half of 90? 45. So each of these angles, when a diagonal cuts a square, each of the corner angles is going to be 45 degrees. You're going to have to know that for one of your problems today. Okay? So, the great thing about a rhombus is all we need to know is one little angle, and we can find the other 9 angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 angles left in a rhombus to find. All I need is that one to find the rest of them. Okay? Let's start with angle 3. How big is angle 3? 90. If I know angle 3 is a 90-degree angle, and I know this angle over here is 53 degrees, how big is angle 1? 30 7 degrees. Okay? Angle 1 is 37, so how big is angle 2? 37, because in a rhombus, these two are the same. When diagonal cuts them, they're the same. What's angle 4? How big is angle 4? 90. How big is angle 5? Well, if this is 53 and 37, and this is 37, what's angle 5 have to be? 53. Angle 6. How big is angle 6? 53. How big is angle 7? 90. How big is angle 8? 90. How big is angle 9? 53. How big is angle 10? 37. How big is angle 11? 37. Can you handle rhombuses? Okay. Once you know one, you can figure out the rest of them pretty easily. All right. So, if QPT, some of you still might not know what this means. What does that mean? Well, we're looking at the P angle of QPT, and we're looking at this one right here. Okay? I'm not looking at angle Q and angle P and angle T. I'm looking at angle QPT, which is the P part. This is 23. How big is PST? This one over here. Well, if this one right here is 23, how big is this one right down here? 23. And I know angle T, no matter where I'm at on angle T, it's 90. So what's left for PST? How much is left on that triangle? 67. 67, because 67 and 23 make 90, right? And 90 and 90 make 180. Okay? Rhombuses. On a rectangle, the diagonals are congruent. They are the same length. If BD is 13, then AC is 13. They are going to be the same length. Okay? I don't like that problem, so we're going to skip it. A volunteer, whoa. I don't know what I just did, but I know what I just did, but all right. A volunteer group is planting a butterfly garden in a portion of a rectangular park. They're going to plant it right in this triangle area here, and that's it. Okay, the butterfly garden is going to go right here. They're going to fence that off. They're going to put a fence here, here, and here. How much fencing do they need to buy for that butterfly garden if they're going to fence it all off? Okay. Now, I know how long KL is. How long's KL? 160. So I know that. I need to know this side, and I need to know this side. Well, what I have here, right here, is a right triangle, don't I? I have a right triangle. If I know two sides of a right triangle, how do I find the third side using some magical formula from a guy from Greece? What's the magical formula if we know two sides of a right triangle to find the third side? It's right behind me. It is the Pythagorean theorem. You will use that today. The Pythagorean theorem says c squared equals a squared plus b squared. The hypotenuse, which is km squared, equals the one side squared, 100 squared, plus the other side squared, 160 squared. Calculators, please, because we need help with this. 10,000, 100 squared is 10,000. 160 squared is 25,600, something like that. So if we add these two together, it's 35,600. And if we take the square root of each side, it's 180-ish. 100 and what? 188 point something. So 188.67. All right. So that's how long this whole side is. Now, diagonals in a rectangle it's still a parallelogram, so the diagonals bisect each other. So take 188.67 divided by 2. That should be 94.335 or something like that. So this part is 94.335. And since the diagonals are congruent, this part is 94.335. So if you add up 160 for the top, 94.335 plus 94.335, you get 348.67 feet. Are we good? Okay. So using the Pythagorean theorem, we can figure out this. Okay, we found out the whole side, and we cut it in half to figure out this part, and then this part had to be the same. Okay. WXYZ is a square. We know WY, this diagonal, plus XZ, this diagonal, is 92. So how long is just WY? Since it's a square, it's also a rectangle, and the diagonals are congruent, so they're the same. So if these two are the same, you have two of the same equal 92, so one of them should equal how much? 46. WY is 46 and XC is 46 to make 92 because they're each 46 because they're the whole length. Now, we don't want WY, we want WP. In a parallelogram, which a square is a parallelogram, the diagonals bisect each other. So how long is WP? If WY is 46, how long is WP? 23. How long is ZP going to be then? 23. The area of a triangle is 1/2 the base times the height. If I redraw the triangle like this, since it's a rhombus, a square is a rhombus, diagonals are perpendicular. My height is 23, my base is 23, the area is 1/2 my base, 23, times my height, 23. Area is 1/2 of 23 times 23. Might be 500 something, right? 5 what? 529. And then we take half of that. So the area is 264.5, right? That's the area. So those are the types of problems that you'll be seeing today. Okay? Those are the types of problems you'll be seeing today. So let's get started with this. Yeah.